you guys know where that name comes from? Why do we call it a square root? Okay, so it comes from the fact that we are literally referring to the side length of a square and what the area formula for a square is. So, let's say I told you the area of a square was 25, for example. How do you find the area of a square? Length times width, and in a square, the length and width are the same, right? So the formula for area of a square is side squared. So in this case, 25 equals side squared. And what would I do to 25 if I wanted to know just s? Take the square root. So that's where the name comes from, because we're literally referring to the side of a square. All right. Okay. So, in the first section, we're just going to simplify square roots or radicals with numbers under them. So, on number 1, what's the square root of 16? 4. All right. What about on number 2 when it says 2 root 49? 14. How do we get up 14? 2 times 7, right. Because the square root of 49 is 7. There was already a 2 there. And we're supposed to then multiply those terms together, right? Good. Okay. What about number 3?
5. Negative 5?
Negative 5, right. Because out front there was that negative. That's like having a negative 1. So it'd be negative 1 times 5, which is negative 5. All right, what about number 4? 9i. Why 9i? Right, so remember on 1.1 we talked about the fact that square root of negative 1 is equivalent to I, right? I could technically rewrite this as square root of 81 times square root of negative 1, and it's still equivalent, right? And we know the square root of 81 is 9. And I told you guys that this was I. Okay? So all we did was manipulate how it was written a little bit so that we could simplify. Okay? You guys have actually done that a lot before. This should say number 5, not 2. But with values that don't have perfect roots. So there's not a perfect square root of 12, right? But I can rewrite square root of 12 as something else. What multiplies to give me 12 and does have a square root? 4 and 3. So I could rewrite this as square root of 4 times square root of 3, kind of like we did on number 4, right? And what is the square root of 4?
2.
So this would just be 2 square root of 3. Okay? So, kind of the same concept, right? Okay, what about 32? What multiplies to give me 32 and has a square root? 16. Okay, so I'm going to rewrite it as 16 and 2, right? That's equivalent to 32. And what is the square root of 16? 4. So I'd have 6 times 4 root 2, which is 24 root 2. Very good. Okay? Number 7. How could I maybe rewrite number 7? Well, first of all, we can't leave the negative with the 24, right? We need to do something like we did here. Okay? So then I could write it as 24 and negative 1. Right, so that fixes part of the problem. But there is still no perfect root of 24. What could I rewrite 24 as? 4 and 6. Good. So 4, 6, and negative 1. So that's what we're rewriting as, right? Okay, what is the square root of 4? 2. There is no square root of 6, right? But we know square root of negative 1 is equivalent to... So I can write this as 2i square root of 6. All right. Okay, what about number 8? What could we rewrite square root of 50 as?
25/2.
Good. So this would be negative 8 times root 25 times root 2. What is the square root of 25? So this is really negative 8 times 5 root 2, or negative 40 root 2. All right, our goal here, guys, is that we recognize in our head that we're allowed to rewrite 50 as this, right? So hopefully we eventually get to the point where we can go straight from here to here without having to write all those steps in between, okay? But that'll come, the more we do these, the more you practice, the easier it gets. Okay, so we've gone over simplification with numbers. Now let's talk about simplification with variables. So first they ask us, what would happen when you square a variable? Well, what does it mean to square something? Right, something times itself. And that's exactly what they wrote right here, right? They've got x times itself, or x times x. What would that be? X squared. Okay? And then they have x squared times itself. What would that be? X to the power 4. What about x to the third squared? X to the what? 6. And what about x to the 5th? 10. All right, so what is happening from the original to our answer? What's happening to the exponent? You're adding them, okay? Is there a specific pattern happening? Something that happens to every single one of them? They're all changing by multiplying by 2, right? They're all doubling, right? So here the exponents were 1. If you double 1, you get 2. If you double 2, you double 3, you get, and so on, right? So when they ask what's happening, we can say the exponent doubles, right? Okay, so you guys know addition, opposite of subtraction. Multiplication, opposite of division. Squaring something is the opposite of taking its square root, right? Okay, so keeping that in mind, we're saying when you square it, the exponent doubles. So what do you think is going to happen when you take its square root? Yeah, we're going to half it or divide by 2, which is exactly what this says right here, right? Okay, now keeping that in mind, if it's an even exponent, that is great, right? If I asked you for the square root of x to the 6th, like you guys said, I'm just going to divide it by 2, right? So this would just be x to the 3rd. Okay, so when our exponent is even, all we're going to do is divide the exponent by 2, right? Okay, what about if the exponent is odd, like x to the 9th? If I divide that by 2, it doesn't come out quite as nice, right? Okay, so what we do in our head, you don't have to do it on your paper every time, is we're going to think about it the same way we thought about some of these. I'm going to rewrite it as something that I can use my rule and get a nice number, right? So the closest even number would be x to the 8th, right? So I'm going to rewrite this as the square root of x to the 8th times x. And that's still equivalent, right? Okay? And now I can look at this exponent. It's even. All I have to do is divide by 2. And I get x to the 4th. But we do need to remember there was this extra one, right? So it would be x to the 4th square root of x is what we would get. Okay? So if your exponent is odd, what you need to do is take away 1, right? We went from 9 down to 8. So take away 1 or subtract 1. And then divide by 2. All right? But don't forget, whenever we subtract 1, we're really saying that it's going to be right here. Okay? It still stays under that square root. All right. So now let's look at some examples where we've got some numbers under the radical as well as variables. So on number 1, we got square root of 169x squared. What is the square root of 169? 13. And then on that x squared, my exponent's even, so all I got to do is divide by 2. So I get perfect. Okay? Number 2, what's the square root of 64? 8. Okay? So I get to take out an 8, but what was already out there? 3. So 8 times 3 is going to give us 24. And then it looks like both of those variables have even exponents, so all I have to do is divide by 2. So I'll just have xy. Okay? Number 3, square root of 100 is times 5, right? And it looks like both of those exponents are even, so I just need to divide by 2, and I get nice. Okay, number 4, what's the square root of 121? And there was already a negative out there, right? So negative 11. X to the right, y to the right. Easy enough, right? Okay. All right, let's look at that next row. These ones are going to have some odd exponents. So remember our rule for odd exponents, okay? All right, first of all, that 32. Is there a perfect root of 32? No, but what did we say you could rewrite 32 as? 16 and 2. And what's the square root of 16? 4. So this is really 4 square root of 2, right? Okay. What about those variables? X has an exponent of 3. So minus 1, which would give me 2. And then I have to divide by 2. Yes, so he said it should just be x. But that one that we took away, where is it? Inside the radical. Good. Okay, for the y, I take away 1, I divide by 2, and I get 2. That one we took away, right, it's right in there. Okay?
Hi.
Hey.
Can I borrow you for a second?
Sure. You guys try 6, 7, 8.
Visual reminder of procedures. Congratulations for making it. Oh, lovely. I like this one too. Thank you very much.
Is there a perfect root of 162?
6, 4, 2.
Oh.
Hey guys, if you have a hard time figuring out what you should choose as your numbers that multiply to give you that value, I would always start by just like asking myself, what is half of that number? So what's half of 162? 81. And does that have a square root? Perfect. So we're going to use 81 times 2, right? Like you guys said, the square root of 81 is 9. 9 times negative 2 that was already out there is going to give us negative 18, right? Okay, but we do still have that 2 under there. Okay. For x to the 5th, what am I going to do there? Good. Nice. Okay, what about y? What are we going to get for y? Y to the fourth. And then a y on the inside. Nice. Okay. 200. What should I change that one into? 102. Good. So I got 102. All right, square root of 100 is 10. Okay. All right, for x, what are we going to get? X to the fifth, X on the inside. And then for y, just a y on the outside. Do we need one on the inside? Nope, because that one was even, right? Okay. Number 8, we got a 50 there. What can I split 50 into? 25 and 2, good. All right. Square root of 25 is, and then what would I get for x to the 8th? X to the 4th. And what about y?
Y to the 4th square.
Nice. Good job. All right, flip it over onto the back. Okay, the last thing we're going to talk about today is adding and subtracting our radicals. All right, so when I am adding and subtracting radicals, might have been a second since you've done this, but we are going to treat them just like they are variables. So when it says, how do they behave like variables. What do I mean by that? Well, let's say I gave you something like x plus y. Could you actually add those together? No. Okay. But if I give you something like x plus x, can I add those together? Yeah. What would that be? 2x. Okay. We get 2x because we are adding those understood coefficients in front, right? 1 plus 1. I didn't do anything to the x's, right? I just counted up how many there were. Okay. Your radicals are going to be the exact same way. So that means if I have something like square root of 3 plus square root of 5, those are not the same. So I cannot add them together. That's like having something like this, okay? But if they match like this, I am allowed to add them together. And I do it the same way I would for variables. I don't add the x's. I don't add the square roots. I add their understood coefficients, which in this case would be 1, right? 1 plus 1 gives me, so that'd be 2 square root of 3. Okay? We following? Okay. So let's see. On number 1, did those square roots match? Yeah. So that means I am allowed to add them. I'm going to add their coefficients. So that would be a 2. This one has an understood 1. And this one is negative 5. So 2 plus 1 is 3. And 3 minus 5 is? Right. So this would be negative 2 root 3. Okay? On number 2, are they all the same? No. Are any of them the same? So the ones that are the same, I'm allowed to put together. Okay? So we got a negative 6 and a negative 4 as those coefficients, right? So altogether that would be, right, so we got negative 10 root 5 plus square root of 2. Very good. Okay? All right, what about number 3? Which ones can we put together? So if I add together the ones that have root 7, I get? Good. And if I add together the ones that have root 3, I get? 3. So 3 root 3. Nice. All right. So do we understand when we can combine? Yeah? And we only combine the coefficients. Okay. Number 4. On number 4, those are all the same, right? So let's combine. 8 plus 9, 17, minus 5, 12. So this is 12 root 27. Now 27 is pretty big. We could probably simplify that, right? What could I rewrite root 27 as? Good. So this would be like this. And what's the square root of 9? And 3 times 12 is nice. Okay. On number 5, do any of those match? No. Okay. So what do you think we could do? Simplify. Okay. What are we rewriting 32 as? 16 and 2. Nice. Okay. And the square root of 16 is 4. And there was already a 10 out there. So 10 times 4? 40. So this became 40 root 2, right? Okay. What about 18? What am I going to rewrite that as? 9 and 2. Okay. And the square root of 9 is 3. And there was already a negative 6 out there. So negative 18 root 2. And then that last one is already a root 2, so it's good to go. Now we can combine. So what's 40 minus 18? 22. And what's 22 minus 5? 17. So this is 17 root 2. All right. Okay, on number 6. What can I rewrite root 125 as?
125 and 5.
Good. Okay. And the square root of 25 is?
5.
And in front of that was a negative 7. So what's that going to be? Right. Okay. What can I rewrite root 75 as?
25 and 3.
25 and 3. Okay. And the square root of 25, like you guys said, is 5. And there was already an 8 in front of it. So that's going to be 40. So we'll have 40 root 3. Okay, what about 45? What can I rewrite that as?
95.
Good. So that square root of 9 is a 3, right? And 3 times negative 9?
Negative 27.
So I got negative 27 root 5. All right, so at least 2 of those match, right? So we got negative 35 and negative 27. What's that all together?
Negative
60.
62.
Yep. Plus 40 root 3, right? Okay. Last one. 128. 64 and 2. Good. All right, square root of 64 is, and there was a 12 in front. What's 8 times 12? So I have 96 root 2. Okay, what about 12? What can we rewrite that as? Mm-hmm. All right, and the square root of 4 is 2, right? So this is going to be a negative 2 root 3 since there was a negative in front. Now 4 root 3 is good as is, right? We don't have to do anything to that one. What about the 18? Good. And the square root of 9 is 3. Mm-hmm. All right, and then we combine the ones that match. So that's going to be your 96 and your negative 3, which would be 93 root 2. And your negative 2 and your positive 4 is going to be 2 root 3. All right.